Welcome students. Today we are going to discuss second part of the numericals in chapter number 2 of class 12, that is solutions. In this section we'll discuss the numericals related with the Henry's law. Henry's law is related with the solubility of a gas in a liquid. So first of all we'll discuss what is Henry's law, what is its mathematical expression, and then we'll discuss its numericals. Suppose there is a liquid taken in a vessel that is shown by green color. Above to this liquid a gas is filled. The pressure of the gas filled is suppose P gas. The gas exerts a pressure on the liquid surface, that is P gas. As a result, some amount of the gas is dissolved in the liquid. Suppose the mole fraction of the dissolved gas in the liquid is X gas. Then as per the Henry's law, the mole fraction of the dissolved gas at a given temperature is directly proportional to the partial pressure of the gas above the liquid surface. So X gas is proportional to P gas. This is the Henry's law. Once again, what is the statement of the Henry's law? The mole fraction of the dissolved gas in a liquid is directly proportional to the pressure of that gas above the liquid surface. If there is a mixture of gases present above the liquid surface, then we should use word partial pressure of the gas. What is partial pressure of the gas? The individual pressure of the gas in a mixture. So the mole fraction of a dissolved gas in a liquid at a given temperature is directly proportional to the partial pressure of that gas above the liquid surface. This is the Henry's law. This equation can be written in the reversed manner. Means P gas is proportional to X gas. If you convert the sign of proportionality into equal to, then P gas is equal to KH into X gas. KH is the constant of proportionality. It is called as Henry's constant. So we have got the equation P gas equals to KH into X gas. This is the mathematical expression for the Henry's law, where P gas is the partial pressure of the gas above the liquid surface, KH is the Henry's constant, and X gas is the mole fraction of the dissolved gas. Mole fraction of the gas has no unit, as it is the ratio of number of moles. It means P gas and KH must be in the same unit. If P gas is in bar, KH should also be in bar. If P gas is in ATM, KH must also be in the ATM. Means both should be in the same unit. So this thing you have to keep in mind while solving the numerical. Now let us see some example of the numericals related with this equation. Find the mass of dissolved dioxin gas in 180 gram water at 294 Kelvin if the partial pressure of the gas is 2 atm above water. KH of oxygen is 35 kilobar at 294 Kelvin. So how to solve it? Here WB means the mass of the dissolved gas is to be calculated. WA, that is the mass of water, that is here as solvent. is given as 180 gram. The partial pressure of the gas is given is 2 atm, and the value of kH is given as 35 kilobar. The equation of the Henry's law which is to be used here is P gas equals to KH into X gas. P gas and KH, these should be in the same unit, but here in this question they are given in different unit. P gas is in atm and KH is given in kilobar. So I will convert them into bar, both into the unit bar. For that purpose, P gas is equals to 2 into 1.01325. Whenever we want to convert atm into bar, we have to multiply by 1.01325. So 2 atm is equals to 2 into 1.01325 bar equals to kh. Kh is given 35 kilobar. To convert into bar, we have to multiply by 10 to the power 3 into X gas. What is X gas? X gas is number of mole of the gas upon number of mole of solvent plus number of mole of gas. For a dilute solution, the number of mole of gas can be ignored in the denominator. Means NB can be neglected in the denominator for the dilute solution. So we can write this equation as 2 into 1.01325 equals to 35 into 10 to the power 3 into NB upon Na. We have neglected NB in the denominator. As the solution is dilute, so number of mole of solute in the solution can be neglected. Now convert the number of moles into masses. You know that N equals to W by M. So it will become 2 into 1.01325 equals to 35 into 10 to the power 3 into NB become WB by MB and Na become Wa by Ma. As Na is in the denominator, so it become Ma upon Wa. Now put the value of MB, Ma and Wa which are given in the question. WB we have to calculate. MB is the molar mass of solute. The solute is dioxygen, so molar mass is 32. M is the molar mass of solvent. Solvent is here water, so molar mass is 18 upon mass of solvent, that is 180. So from this equation WB can be determined. It is equals to 2 into 1.01325 into 32 into 180 upon 35 into 10 to the power 3 into 18. When you solve it, you will get your answer 0.018528 gram. This is your final answer. This amount of dioxygen is present in the solution. Now our second question, calculate partial pressure of CO2 gas above its 0.05 m aqueous solution at 298 Kelvin. The Henry's constant Kh of CO2 is 1670 bar at 298 Kelvin. In this question, KH is given and P gas is asked. But to calculate P gas, X gas is not given. In place of X gas, molality of the solution is given. So you have to extract the required data from the molality. So what things are given here? The value of KH is given, that is 1670 bar. Molality is given, that is 0.05 m. Now how to extract the required information from molality? So I've told you that we have to assume the denominator of the formula of molality in such a way that the numerator become equal to the given value. So write the formula for the molality. Molarity is Nb upon Wa in kg. So I have to assume Wa in such a way that the Nb become equal to molarity. So suppose Wa is 1 kg, means 1000 gram. Then Nb become equal to molality, and that is 0.05 mole. Okay, now number of mole of solvent here, that is Wa by Ma. Wa we have assumed value 1000 gram, and molar mass of solvent is here water, as the solution is aqueous, so molar mass is 18, so it is equals to 55.55 mole. 55.55 mole. Using these moles of solute and solvent, we can determine the mole fraction, and using the mole fraction and the value of KH, we can calculate the value of P gas. So let us see at the next page. P gas is equals to KH into X gas, where X gas is equals to Nb upon Na plus Nb. We know the value of KH. The value of KH is 1670 bar into number of mole of solute 0.05 mole, number of mole of solvent 55.55, that on rounding off become 55.56, and Nb again 0.05. If you solve it, you will get your answer, and that is 1.5015 bar. Why the unit is bar here? Because KH is in bar, so P gas will also be in bar. So this is your final answer. Our third question is, find Henry's constant for N2 gas in kilobar at 300 Kelvin. The partial pressure of N2 gas above its 0.9% by mass aqueous solution is 800 millimeter of Hg. Here in this question, P gas is given, that is 800 mm of Hg, and Henry's constant Kh is asked in the unit kilobar. It means the unit of P gas and Kh are different. We have to convert the P gas from unit mm of Hg to kilobar. Then only you can get the value of Kh in kilobar. And another thing, X gas is not given. In place of that, mass percentage is given. You have to extract information from the mass percentage. So let us see how will you do this numerical. First of all, I will convert P gas into kilobar unit. You know that 760 millimeter of Hg is equals to 1 atm, and that is equals to 1.01325 bar. So 800 mm of Hg will be equals to 1.01325 upon 760 into 800 bar, and this on solving will be here 1.0666 bar. On converting it into kilobar, you have to divide again by 1000, so it become 1.0666 into 10 to the power minus 3 kilobar. So in this way we may convert 800 mm of Hg into kilobar. Now mass percentage of the solution is 0.9%. You know that the mass percentage is Wb upon Wa plus Wb into 100. I have to assume the mass of solution in such a way that the Wb become equal to mass percentage. So suppose Wa plus Wb is 100 gram, means the solution is taken as 100 gram. Then Wb as per the question will be equal to 0.9 gram, and therefore Wa will be 100 minus 0.9 means 99.1 gram. So I have extracted the masses of solute and solvent in the solution from the value of mass percentage. Now using these Wa and Wb value, we can calculate the mole fraction of the solute in the solution, and using that value we can determine the Henry's constant. Let's see at the next page. Use the equation for the Henry's law. P gas equals to Kh into X gas. X gas is not given, so Kh is equals to Nb upon Na plus Nb. Na and Nb are also not given. In place of that, we have extracted masses of A and B from the mass percentage. So I will convert moles into the masses. So P gas is equals to Kh into Nb is equals to Wb by Mb. Na is Wa by Ma, and NB is again WB by MB. Now put all values. P gas is 1.0666 into 10 to the power minus 3 bar equals to KH. We have to determine WB. WB is 0.9 upon molar mass of the solute. Molar mass of the solute is 28, as the solute is nitrogen gas. The formula is N2, so molar mass will be 28 upon WA, that is 99.1 gram, upon the molar mass of solvent. For water it is 18 plus again 0.9 upon 28. When you solve it, you will get the value of KH equals to 0.1846 kilobar. So this is your final answer. In this way you can use the equation of Henry's law. So this is all about the Henry's law and its numerical. Thanking you.